We will try to look at one final algorithm, which is quicksort. Consider quicksort. Suppose this is the array which was given to us. Quicksort is actually having a pivot element. Pivot element can be taken as the last element, the first element, the middle element, the median, anything, or any random element can be pivot element. In this case, let's try to take the last element as pivot element. I'll try to call it as x, and I'll be having a pointer which is called low, and I'll be having another pointer which is having high. Low pointer will actually keep all the elements which are lower than the pivot element at a particular instance, and if a particular element is higher than the pivot element, from the right we will be having those elements after the high pointer. Let's try to see how quicksort works on this array. Initially we are having low pointer and high pointer as we have discussed. High pointer will be incremented and will be pointing to this point. 30 is greater than 10. So the required element is higher than this element. This will be left as such, and high pointer will be incremented. 20 is greater than 10. Again high pointer will be incremented. 50 is greater than 10. Again high pointer will be incremented. 70 is greater than 10. High pointer will be incremented. 80 is also greater than 10. Now finally it has almost reached the pivot. In this case, all these elements which are on the left of the low pointer are less than this. So the correct position of this pivot element is next to this low pointer. The low pointer is at -1 and the correct position of pivot element is 0. This has to move to the first position. Now the array turns 10, 20, 50, 70, 80, and as both of them are swapped, 30 comes to the last. Again, if we try to repeat this approach, low pointer is initially at -1, high pointer is also initially at -1, pivot is at the last position. High pointer will be incremented, 10 and 30 will be compared. If you just observe, 10 is less than 30. So we have found an element which is less than pivot element. We will try to increment the low pointer and we will try to exchange both of them. In this case, both high and low are at the same point, even though we will try to swap the values at this high pointer and low pointer. Again, we will try to increment the high pointer. If we just observe, 20 is still less than 30. That means we have found another element which is less than the pivot element. So we will increment the low pointer and we will exchange with this. Basically, we are looking for the numbers which are less than the pivot element, and whatever number that we have seen, we will try to keep track of them with the help of this low pointer. And once all the elements which are less than this are arranged to the left of low pointer, we will try to take this element and will place it in the position of low plus 1, which is actually the correct position of the pivot element. In this case, we are trying to solve each and every number till the entire array is sorted. This is the approach of quicksort, and taking an element and putting it in its correct position. This approach is called partition. By default, quicksort is a not stable algorithm, but it happens in place. It is not actually using any extra memory other than the input that we have provided. If we try to analyze the time complexity, it will take order of n square in the worst case. The worst case actually happens when the array is completely sorted or when all the elements are equal. It happens because it requires all the comparisons in both of these cases. You try to take an ascending order array or descending order array and try to solve in this approach, and you will find that it tend to behave more worse than in the normal case. So the complexity in this case turns out to be order of n square. But in all the other cases, the complexity turns out to be order of n log n. This also uses divide and conquer, because we are trying to take a particular element and then we are trying to place it in its correct position, and we are repeating the same approach for the entire array. This is how quicksort is solved. Now we have seen the basic concept of the most important sorting algorithms. If you want to read about them in detail, you can go check them out in Geeks for Geeks or any other website.